So let's start by breaking this question down a little bit into smaller chunks so we can better understand. It says, can the area of rectangles remain the same for different perimeters? So let's start off by, what is area of rectangles? What does that even mean? If we're talking about the area of rectangles, what am I talking about? That shouldn't be a trick question. We've been dealing with area for a little bit now. Now, what am I talking about when I'm talking about the area of rectangles?
How much is in the rectangle?
How much space is in the rectangle? Okay, so can the space inside the rectangle stay the same? We know what stay the same means? Yeah, easy. For different perimeters. What does that part mean? Okay. This one's to be read today. That was blue. What is different perimeters? What does that word perimeters even mean? When I'm talking about perimeter, what am I talking about? Trick question either. Alan?
How much space is on the outside?
How much space is on the outside? If I could break apart that rectangle and make it one long line, how long is the outside, that rim? Okay. Pen can't decide if it wants to be red or blue. A little bit of both.
Did that ask you this?
Yeah, I don't know what it's doing. So can rectangles that have an area that is the same, can that work if the perimeter is different? It's kind of a tricky question. Can two different rectangles that have the same area have different perimeters, or do they have to have the same perimeter? That's tricky. That's tricky. We're going to keep that question in the back of our head, and we're going to move on and hopefully have another way to answer that. Let's go ahead and draw this shape in your notebook. It doesn't have to be counting the specific lines down, but it does need to be straight because there are lines in your notebook. And I just want you to find the area of this shape. I gave you a 5 by 6 rectangle. Please label your dimensions. Please write an area equation to solve the area of this shape. Georgiana, what you need?
You forgot to label all of your area, your dimensions.
Alright, when we think of area, I want you to think about what word? Remember? Area looks like an array. Area is just another version of an array. So when you see area, you should automatically think array. If I'm thinking array, what mathematical equation am I going to use to find area? Courtney?
10.
multiplication. Yep. How many rows do I have in this model?
6.
Rows. Rows go across. No, 6 is going up and down.
Yeah, that's column. 5.
So 5 rows. And how many columns do I have? 6. This is my area equation. I'm writing it in the inside to remind me, oh yeah, that's area. 5 times 6 is, we should all know this one pretty quickly, Dylan. 30. Now I'm doing area, so what's going to be my unit?
Square units.
Square units, because I'm using an entire square to fill up my space. Now I don't know what unit I'm using. I don't know if I'm using feet, inches.
Yards, miles.
I don't know. So I'm just going to say square units. Are we good with that?
Yeah.
Georgiana, question about that?
I'm
Good?
just about to say you forgot square units.
Gotcha. Thank you. What's the perimeter of this shape? Solve it. I need an equation. I need an equation. Perimeter. See the word perimeter. What do I want you to think about? When you see the word perimeter, what is that word I want you to be thinking about, Eva?
How much is in the inside of the shape?
No. Sam?
Addition.
You can think addition, sure. Mason? Sure. Lucy? The rim. It is in that word, perimeter. When you see perimeter, I want your pencil to walk around that shape. It might be a square. It might be a triangle. It might be some crazy shape. But your pencil needs to walk around the shape. This is where labeling your dimensions is going to come in handy, because I guarantee there will be an answer choice of 11. You know why? Because there's a 5 and there's a 6. And 5 plus 6 is 11. Is 11 the perimeter?
No.
Nope. So if you came up with 11, you successfully got tricked. Label all your dimensions. So what do I mean by take a walk around the shape? Well, hopefully you've labeled each side. Perimeter, as Mason told us, is addition. Here's my pencil. I'm going to start in this corner and I'm going to walk up this side. Please do this. How many units did I walk to walk that side of the shape? Not a trick question. It's there. How many units? Cheyenne? 5. Did I have to draw tiles to know that? No. You have to just imagine that they're there. 5 plus, keep your pencil going around your shape. Now I'm going to go this way. Maybe. Come on, you can make it. Alright, we made it across, kind of. How many units did I walk to get across the top of that shape? Eva? 6. Did I walk around the shape yet?
No.
No, so is my answer 11?
No.
Don't get tricked. Alright, now I have to come back down, Ella. How many units did I walk? 5. Did I make it all the way around yet?
No.
No, Gabriella, I need to go to the bottom. Now I'm at 6. This is what your perimeter equation should look like. What if I wrote it in this order? What if I wrote it in that order? Would that be a problem? Raise your hand to answer. Or?
Yes.
Yeah? Why?
Because it's still the same numbers altogether.
So is that a problem? There are two operations that can follow the commutative property. One of them is multiplication. Lucy? Addition, you can use commutative property too. 3 plus 2 is going to give me 5. And 2 plus 3 is also going to give me 5. My order for addition doesn't really matter. So if this makes your brain happier down here, go uptown. Okay. What is my total perimeter then? What is my total perimeter? Probably should be using your notebook. Staring at me is not going to help you. Taisha, what's my total perimeter?
22.
22. 22 what? Unit. Go. Beautiful. Beautiful. It's going to be just units because I didn't use the entire square in that walk around. I only used one side of that square as I went around. Lucy, what's that? Alright, we have this shape. I'm going to label my dimensions. I can tell opposite sides are equal on a rectangle, so this is going to be 3. This is going to be 10. I'm asked to find the area. Area equals array, which would be multiplication. What's going to be my area equation? What is my area equation? Go for it, Ella. 10 times 3, you could do it 3 times 10 if that makes your brain happy. What's going to be the product of that multiplication equation? Georgiana?
30.
30.
30 units. 30 square
units.
area.
We're an area, so we got to use all of our, I can't write my square units. I don't know why it doesn't want me to write you. There we go. Area uses whole squares. Yep. Are we good with area?
Yes.
Good. What's the perimeter of that shape? What's the perimeter of that shape? I need an equation. I need an equation. If it helps you, literally draw your pencil. Walk around the shape with your pencil. As you cross off a side, or as you walk that side, add it to your equation. Better question. Walk around the shape. Courtney, walk around the shape with me. Where do you want to start? 10. Alright, we're going to go across. So we got 10. Then what?
3.
Give me an operation. A math operation.
Oh, sorry. Addition.
Yep. So we're going to add. Plus. Now what? 3.
Plus. 10. Plus. Plus 26.
26.
Square.
Did I use whole squares?
Oh, no. It says units.
Just units. Just units. Hey. Didn't the shape before have the same area?
Yeah.
What did the shape before have? Yeah, with 30 square units. Can the area of rectangles remain the same for different perimeters? You just made two rectangles that have the same area. Did they have the same perimeters?
Yeah.
No. Look, you have a notebook.
I live
You still have it written down. Look.
Nope.
Can the area of rectangles remain the same for different perimeters? If I draw a shape and then I draw another shape that has two different perimeters, can the area still be the same? No! Stop calling out and actually think. This is worded very tricky. If I draw two rectangles, just like you did, they both have different perimeters, correct? Yes. Can the area stay the same even though those perimeters are two different perimeters? What do you think, Susie?
Yes.
Yes.
Okay.
Two rectangles that have the same area do not have to have the same perimeter. Two rectangles that have the same area do not have to have the same perimeter.